carbon element only without the H element. So if it's carbon element only, if you learn back the basic chemistry last time, it is what we call as graphite. Okay, so it is a non-hydrocarbon content. All right. So seal rock is when we have reservoir rock, we need to have another rock layer on top of the reservoir which is able to seal it. So if you have reservoir rock without a good seal, you will not have an accumulation or a pool of hydrocarbon. You tend to have the hydrocarbon to be scattered. So that is not what we want. We want a petroleum system with a huge amount of hydrocarbon accumulate in one location. So if you have a lot of hydrocarbon but it is scattered, there's no point. Because if you want to drill location of a different position in a large field, it actually consume cost. Okay, the drilling rigs and everything. And then overburden rock, okay, it is above the seal rock. So the more rock layers deposit on top of the seal rock, the pressurized your petroleum system will be. Okay, so pressure is crucial in the petroleum system because if there is change, if you have an unstable rocks, it will cause pressure change, and this might cause an impact to the platforms, to the oil rigs. Okay, and if you could recall back, I mean, if you have heard about the big Horizon, Deepwater Horizon case where there's an explosion. Okay, someone. Okay, so there's an explosion just due to that pressure, minor pressure change.
ஹரிஷ் எப்படி ஹரிஷ் இப்ப நான் கணக்கு சொல்றேன் பாரு, நீ கரெக்டா இருக்க நீயே பாரு. டாப் வியூவோட அந்த கோத்தா வந்து ஹைட் வந்து 42 இருக்கும், லென்த் வந்து 60. அது முதல்ல ரைட்டா?
Gobinath Naidu, can you mute your Okay, anyone who is friends with Gobinath, can you inform him to mute? Okay, alright.
ஏன் அந்த குரூப் அப்படியே என்னது? அச்சச்சோ,
Gobinath.
அத சொல்லலாம் கால் பண்ணியா?
Gobin. Okay, alright, so if any fluctuation of pressure, even minor change in pressure, could cause an explosion. That is why if you want to pursue a career in the oil and gas, it is equivalent to risk. So that's why the salary is high. Okay, so pressure is crucial to make sure. So if your petroleum system, all the rocks are in stable state, so it is safe lah. We could give we can ensure that we can assure that the safety of the staff that is going to the offshore is safe. And then we have the exploration techniques, which as I mentioned before, there are seismic method and non-seismic method. Non-seismic method are the magnetic and gravimetric survey, and we have the seismic method. And then the exploration and appraisal well. Okay, so exploration well is what we call as, some term that we use is the wildcat, meaning that wildcat, we explore an area by putting a well there by just try and error whether there's oil and gas or not. Okay, so that's what we call as the wildcat. And once during that, when we drill through for the exploration well, if there's hydrocarbon, then we will proceed for the appraisal well. Appraisal well meaning that you are going to conduct the interpretation of the rocks, the fluid properties, and also the rock properties. and also interpreting the whole petroleum system. Okay. Okay, it seems that I cannot go to the next slide, but I think all of you have the materials. Okay. Um, okay, so I'm sharing the screen. I hope it's clear. All right. So the origin of petroleum, rock cycle, sedimentary basin is where the fields, what we call as the field of the hydrocarbon pool. And then why do we call it as basin is because, as you know, basin is like a container of a container lah. So we call it a sedimentary basin, which means that space which contain the sedimentary rocks. Okay, so the petroleum system, which consists of the source rock, the seal rock, reservoir rock, all contained in the sedimentary basin. Okay, conventional and unconventional reservoir. Okay, so this is the rock cycle. Okay, so we have the three basic types of rock: igneous rock, metamorphic rock, and also sedimentary rock. Okay, so it is a cycle, meaning that whatever rock type it is, some processes will cause an effect to it, and it may change into the into a dispersed sediment, or it could become a magma. Okay, so for example, igneous rock undergoes melting, it will become magma. Igneous rock undergo weathering and erosion, it will become particles of sediment. And then igneous rock undergo heat and pressure, it will convert into metamorphic rock. So the thing for metamorphic rock, they could change. Igneous and sedimentary rock could convert to metamorphic rock through the heat and pressure processes. And then metamorphic rock undergo same processes of weathering and erosion, it will convert to sediment, similar with the sedimentary rocks. Okay, so you need to at least understand that what are the processes involved for the rocks to convert or to change into materials, okay, materials of sediment or magma, right? And then these are the definition of the rock cycle. So this describes the diagram. So igneous rock, okay, so all rocks are made up of minerals. Minerals are formed, as you know, it is made up of chemical components. So for example, the simplest mineral that is close to you is halite, which is sodium chloride, salts. So as you know, in salts, we have Na and also Cl. So when these two ions combine, it becomes a compound. So this chemical compound is the mineral. So in the rocks, we have a lot of minerals. So for igneous rock, the minerals it is formed through magma sources. So inside magma, we have ions. So when these ions crystallize, it will become crystals, which we call as minerals. So so does the sedimentary rocks. So in sediment, as you know, we have sand, we have mud, or clay. So this sand, mud, and clay are composed of crystals.
என்ன அசிங்கப்படுத்தாங்க, எல்லாத்தையும் எரிச்சிருவேன். இரு.
The problem right here.
Okay, guys, I didn't realize that I was out. Can one of you up to where discuss the topic? Only one representative. Can you? Okay. Because Microsoft. Okay. How about like this? I think all of you have read the lecture notes, right?
I'm wondering which lecture note, Miss. The first one or the second one?
The one that I display.
The introduction, right?
Yeah. Introduction to oil
Right.
and gas exploration. Or
Yeah.
how about like this? Can we not display the material? I will not display the material, but I will explain based on the lecture note, the one that upload for this session.
Okay, doktor. Boleh.
Kan? So you guys just flip through to the next pages in the PDF je lah.
All right, sure. Noted, doctor.
Okay.
Oh yeah, I'm wondering why not we separate like we separate to different group, because I'm afraid that the server is overloaded, so they can't. I mean, the server can't handle that much load. So
Yeah.
why not management just separate us to different groups, different servers, like for each server can contain like 40 students.
Probably.
Limit kan? 200.
Can someone mute the mic, please? Thanks.
guys.
Yes,
Yes, sir.
we could hear you,
Hello,
doctor.
You can hear your. Oh my God, I'm so sorry.
It's okay,
So-
sir.
It's
okay,
complicated, you
sir.
know, when dealing with this one. So can you invite your friend also?
Yeah, sure, no problem.
Yep.
Try to post a link.
Yep. Thank you so much.
Welcome.
Sir,
Yes. Yeah.
is it possible like we just watch the pre-recorded video?
Yeah, it's
Oh.
possible if you. Okay, it's like this. This class on Friday is just for recap, because maybe some of you don't understand like what you're going, what is basically being presented in the open learning, right? So that's why UTP had put an initiative to give extra recap class for you, so to give you better understanding. I'm so sorry because I'm also encountered the same thing when I called the ITMS. Oh my God, when dealing with this one.
Sir,
Yep.
with all due respect, I'm wondering, could we separate into different sessions, like computer?
But do we have enough lecturers for us?
Okay, it's like this. Next week, I'm going to divide you into 3 groups. So each of the group will be allocated 40 minutes to 40 minutes for the class sessions. But I don't know. It depends on the BBB itself, If the BBB itself can work, we can do the class like this. If cannot, we cannot do anything. Yeah.
But BBB can't handle much load actually. Just now,
Yeah.
many of us can't enter the
Actually, it's like
session.
this. I already lodged a report to ITMS. I talked to them that we encountered the problem last week, right? So he said to me that they already increased the viewers from up to 2,000. So that's why they insist us to use the BBB. So, but it's okay. Can we start our class? We are waiting for Miss Nabila to give a lecture. I'm so sorry. It's very, when dealing with all internet, everything's is quite complicated.
With all due respect, sir,
Yeah, it's okay.
I think can
So-
only contain 250 students only.
Pardon?
Can only accommodate 250 students, I think, for MST.
Yeah, that's why we use the live, right?
Yeah, is this live?
I don't know because your friend said it's a MSD live.
If live cannot communicate like this,
This is MSD live, right, guys?
I'm not
I
sure.
think this is Microsoft Team normal one because live
Mm.
cannot have chat box or the audience cannot talk.
Okay, if they can you forward an email? Not forward email. Can you give the link to your friend who who cannot enter this one? Is that possible? Yeah, using the Discord. Can you share the Discord with your friends?
I got a link for YouTube live stream, so maybe I will share that one as well. Because Discord, there's a bit of distortion, so I guess that YouTube will be better.
Okay. Thank you so much.
Alright, sure, welcome, sir.
Yeah.
Okay. Until where did I explain? Is it this slide on rock cycle?
Rock cycle, I think.
Cycle.
This one, plate tectonic.
Yeah,
Okay.
that one.
Okay. All right. So so the magma source in mantle layer is the one that drives the plate movement. So when you have plate movement, that is one of a source to your causing unstable to the petroleum system. As what I've mentioned before, we do not want an unstable petroleum system because it will cause an impact to us as human being and any facilities on top of the petroleum system. Okay. All right. So this is the sedimentary basin. As I mentioned to you, sedimentary basin is like a field full with sedimentary rocks. Okay. So sedimentary rocks, we have all those types of crucial elements of the petroleum system, which are the source rock, reservoir rock, seal rock, and also the overburden rocks. Okay, so what is this? Is the location whether it is at the ocean, in the ocean offshore, which is color coded by this orange color, or it could be at a shallow water.
I'm sorry, but I can't hear anything.
Hello, madam. Are you there?
I'm sorry, doctor, but I guess you have been muted.
Okay.
I could hear you, doctor.
All right. Okay. All right. Okay, so we are going to start with this slide. Okay. So this orange region
Madam. Hello.
Miss, you have been muted again. What a bummer.
What happened?
Okay.
Could,
Is it automatically
anyone,
muted?
please?
Ke?
I guess I'll accidentally click the button or maybe play a trick or something. I don't know. Please
Okay.
to mute.
So please do not click into any of the buttons on the interface, because I've unmuted, so suddenly I'm being muted again. Okay. 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 So can you listen to me?
Yes.
Okay.
Yes, miss.
Yeah.
Right.
Hear you.
Very clear, very clear.
Okay. So okay, at the third time. Okay, the orange region is where the sedimentary petroleum system are, which is at a deeper depth, and we have the green region, which is at offshore but at a shallow water depth, and then we also have a region which is this dark pink, which is near towards the onshore, usually at the transitional part of the land and also at the shallow water depth. And then we have at the regions of the petroleum system on a cratonic area. Cratonic area meaning that regions which are active with the plate movement, the tectonic plate movement. So previous slide, the source of that movement is due to the magma in the mantle layer. So most probably these cratonic areas, they have the magma source actively moving below this plate Okay, so if it's actively moving, so it will affect the field colored in this light purple cratonic area. Okay, so sedimentary basin is just an area which have all the petroleum system element, all the sedimentary rocks deposit in that area. Okay, so depression is a term in the geology which is a space on the crust. So without a depression, without a space on the crust, you will not have all these sedimentary rocks to deposit in it. Okay, so the shape of the field, it first must be there for accumulation and deposition of sedimentary and sediment layers to be deposited. Okay, bowl shaped. All right, conventional and unconventional reservoir. As I mentioned to you before, conventional reservoir are hydrocarbon, oil and gas, which is in rocks that are common type, which are the sandstone. Okay, sandstone, ideally we know that it has good porosity and permeability. So we have established techniques, a lot of techniques to explore conventional reservoir. That's why we classify a field as conventional reservoir, because meaning that we have any techniques to choose, the current techniques to choose to explore this conventional reservoir. So what happened is that we also have hydrocarbon trapped in unconventional reservoir. Okay, unconventional reservoir rocks mean the rocks are not porous, not permeable, but they have a lot of abundance of hydrocarbon in there. So if when we calculate it, the amount is equal to quite large amount of profit that we could get, we will explore for this type of reservoir. The thing is, why do we need to calculate up to the profit part is because the unconventional drilling and methods to explore for this type of reservoir cost a lot. So if we explore unconventional reservoir but the amount of hydrocarbon is too small, we will not go for it, because you will have loss rather than profit, because the cost to have this to explore this unconventional reservoir is expensive. Okay, so basically it's just the type of rocks. Unconventional reservoir are hydrocarbon in tight sand, meaning that low porosity, low permeability rocks. It could also be in shale. Okay, if you look into cross section of rocks, they sometimes color the rock layers to give an interpretation, which is shale usually gray in color or black in color, and sandstone they will color it somewhere a lighter color, light brown, and white color are usually limestone. Okay, it could be limestone or sometimes salt. Right, so petroleum system, these are the 4 types of rock. So the amount of organic matter inside a rock plays an important role. So the usual type of source rock is shale. Okay, why? Because shale have low permeability. So when you have organic matter inside a low permeability rock, it's easy for it to contain. And then when it undergoes high temperature, it will easily convert into hydrocarbon. So that's why the host rock, which is the source rock, must have low permeability. Okay, it's okay for it to have high porosity, meaning that it can contain a lot, but it's crucial that it is low permeability so that it does not flow into different layers. Okay, so source rock, so we have source rocks that generate oil, rocks that generate gas, and rocks that also generate both, and also coal. Coal is another type of source rock. So you have 2. One, it could be source rock, it could be coal, another one it could be shale, right? Okay, so how is it that we have different type of oil and gas generated is based on what dye inside the rock. So if you have animals which have lipid layer, they have lipid layers in their body, so it will tend to convert into oil. if you have plants usually, when they die, decay, it will tend to convert into gas. So that will give you some idea. So if people ask you, they are exploring a reservoir which consists of oil only, meaning that the organic matter inside the source rock consists only of animals that decay inside it. And if you have on gas reservoir only, then it means that in the source rock, only plant decay inside that rock. And if you have both, so meaning that you have plants and also animals die in that decay in that source rock. Okay, so this is the ideal picture of a petroleum system. In reality, this is not what is displayed lah. It is much more complex. It is much more different geological structure, and the layers of the reservoir rock is not as lateral like this lah. In reality, it will be so much challenge that you have fractures in this reservoir, and your reservoir rock is somewhere dispersed into different location. So that's why if you look into a field and they have different location of well being drilled, it shows how complex the reservoir system, the petroleum system of that area. Okay, so for this case, usually we just drill one well, penetrate until the region here into the reservoir rock, and then they just produce everything out into one well. But you imagine if you have complex reservoir rock, which maybe some of the reservoir rocks are in this location, another reservoir rock location there, that's where we drill at a different location. So we need to drill areas with sufficient amount of hydrocarbon that will, when you produce, it will give you a profit. Right? So this is an ideal case of the petroleum system. Source rock, migration. Arrow shows the migration of hydrocarbon from source rock travel into the reservoir rock, and they will accumulate there. And as you can see, reservoir rock can happen if you have a good cap rock. Cap rock is equivalent to seal rock. So your seal rock must be very low permeability, very low porosity. So it will prevent the hydrocarbon, oil, gas or water to penetrate through the cap rock. Okay. And you can see that the arrangement here, it shows the different density of the fluid. So as you know, gas have the most lowest density, water most density. So that's why naturally the less dense one will tend to travel upwards and followed by the dense fluid. Okay. Reservoir rock.
I have a question right here, Miss. I'm wondering what happened if the cap rock is not a good rock? I mean, you have porous, it got cracks.
Okay, good question. So it will cause a major impact to anyone who plan to drill this area, because if you have the drilling team, the crew come there with the items to drill, and you have a very poor cap rock, it is fractured, it is penetrable. What happens is that the moment you drill, the whole equipment, the crew on top, the one that is on top of the seabed will cause an explosion lah. When you try to penetrate into a high pressure system, it will cause a blowout, an explosion, and the impact is quite crucial because when you want to drill, it involves a fluid system, mechanical fluid system, hydraulic system to penetrate through, and you have flammable liquid, flammable fluid below. That is the source of explosion. So that's why the geologists, you need to interpret properly the properties of the rock layers inside the petroleum system. What is the rock compressibility, the rock strength, if it's and these properties we can have some idea from seismic section. Okay, in seismic interpretation later on, for the geologists, they can come out up to 4D interpretation. meaning that they are able to characterize the properties of the rocks in terms of dynamic properties, dynamic change. Okay. So yeah, cap rock is crucial. Without the cap rock, everything will be a failure lah to the operation.
So what does the cap rock made of? I'm wondering.
Any rock with low porosity and low permeability, usually shale. Sandstone, yes, but if the sandstone is low porosity and low permeability. We could also have limestone. So the key point is just the properties of the rock in terms of porosity and permeability and the thickness of the rock. Because as you know, that's why the overburden rock, which is usually on top of the cap rock, is crucial because it will cause a much more stable system when you try to penetrate through the reservoir rock. Okay, right. So yeah, as what I've mentioned several times about reservoir rock, the ideal one, what we want is just a good porosity and good permeability. So we could also have reservoir rocks which are made up of limestone. And as you know, a close picture, if you have been to the areas at the beach, you can look into the coral reef formation. Okay, if you guys go to snorkeling and everything, if you look into the reef closely, some of the coral reef have pore spaces, holes. So when this coral reef convert into, it is being deposited with layers by layers of rock and become pressurized, they will convert into limestone. Okay, because the skeletal are made up of calcium CaCO3, calcium carbonate. Okay, so the key thing is that limestone and sandstone can be your reservoir rock as long as it has the porosity and permeability. So the example that I gave it here, sponge, which as you know, sponge have a lot of pore spaces, and sponge contain the liquid fluid, the hydrocarbon. Okay, so that's why the example here, the most simple example that can be used is the sponge lah. Okay, so you need to bear in mind reservoir rock is just a place for accumulation. Seal or cap rock is the one that will trap the hydrocarbon. Okay, so this is how reservoir rock look like if you zoom in under magnification. So pore space is the space between the grain here, and usually permeability, how we define it, is based on connection between the spaces. So for example, the purple spaces here is where we identify whether it's permeable or not permeable. So if it's not permeable but it's high porosity, meaning that this space is abundance, but it is not permeable, meaning that there's no path for liquid to flow when it contained inside these spaces, in this pore space. Okay, so make sure you are able to differentiate between porous and permeable. Okay, all right. So seal rock or cap rock, impermeable, not permeable, it could be porous. So these are the type of rocks. We could have shale, salt, okay, anything that has low impermeable rock. Okay, so this is the unit that we use to quantify permeability. It is in Darcy. So the ideal for a good reservoir rock, the value is at least 100, around 100 millidarcy. Okay, so this is Darcy. So 1 Darcy is 1000 millidarcy. So 0.1 Darcy is 100 millidarcy. So if you have 0.1 Darcy, it's good enough as a permeable rock. Okay, so this is again another picture showing the petroleum system generation process in source rock, and then it travels through. For this case, there is a fracture there. This yellow line is the fracture. It's the conduit for hydrocarbon to flow into a layer of rock, which is the reservoir rock, and on top of it, it has a seal rock, and then you could have accumulation of fluid in there, which are the gas, oil, and also the water. So the process of accumulation occur in reservoir rock, migration at the fractures, and it could be, if you do not have fracture, hydrocarbons still can flow throughout the rock layers. So fractures will have a faster flow compared to hydrocarbon flow through rock layers. Okay, and here there is a temperature window, which is around this temperature range. You could have hydrocarbon generation. Beyond this temperature, you will not have the hydrocarbon will not be generated from the organic matter. It will turn into a non-hydrocarbon, C only. So the compound will have carbon compound only. Okay, overburden rocks, any rocks that is on top of the seal rock. So okay, now the layers here between reservoir rock and the source rock could be your overburden rock, as it will cause a pressured system to the source rock, and the seal rock above the cap rock will also give a different strength to the impact to these rock layers below it. So basically the overburden rock is crucial to give a pressured system to convert materials for the source rock. Okay, what is this? Alright, overburden rock. For this case, pot of. Okay, green is source rock. And then the light brown here is the overburden rock. You have your reservoir and seal there. Okay, so this is one type of basin. As you can see, it's not just the ideal picture of this petroleum system. It could be distributed differently like this manner. For this case, you have source rock, but you do not have reservoir rock on top of it. Layers of sand tend to deposit only at this region, and then you have a different rock layers deposit there. So this is subjective to the geological field of where the basin is, and the distribution of the sand, distribution of the mud, the clay is crucial to show the extension of the rock layers when it undergoes a pressure system by the overburden rock. So for this case, the reservoir rock, for example, the sand sediment, and the green layers are the mud. They distribute just on top of here, but it doesn't go beyond that. But eventually you have the overburden rock layers deposit. So that's where the extension of this reservoir is only up to this region. So that's what geology need to do. They need to interpret why and how does the sediment deposit only at a certain region. There must be an impact of weathering or erosion taking place during that years. So when we talk about geology, we're talking about million years ago, what happened. So that's the role of geology, to interpret this. Okay, exploration technique. Exploration technique uses the physics, the concept of physics. So it's just any physics element that we try to shoot underground, and we will try to retrieve it back through data on surface. Okay, so we have magnetic, we could use the magnetometer. Gravimetric, we use the gravimeter. Seismic, we will use the source of explosion. So, and a receiver. It must have a source and it must have a receiver. Okay, so the concept here, magnetic, is, as I mentioned to you before, rocks are made up of minerals. So minerals, they're composed of a lot of chemical elements. As you know, we have metallic and non-metallic ion, which depend with the chemistry, the chemical compound of the mineral. So for those which have magnetization effect, minerals which have magnetization effect, it will give a significant reading under the magnetic technique. So we can look into, this is more on looking into the type of rocks. We cannot identify the type of hydrocarbon from this magnetic technique, and we do not know the fluid type in this method. We only know whether the rocks have magnetic minerals or non-magnetic minerals. So to interpret geology only, yes, this is one way, but for our case, we wanted to know whether there's hydrocarbon or not. So that's why it is crucial for us to go for seismic method. Okay, magnetic and gravimetric is just trying to get what type of rock. So gravimetric, it is sensitive to density. So just to give you some idea, as you know, igneous rock comes from magma. Magma is like a very viscous layer. So you imagine this viscous fluid convert into a rock. So igneous rock will have a much higher density compared to rocks that is made up of sediment, like mud or sand, like sandstone or shale. And metamorphic rock, you imagine if metamorphic rock, it is generated from igneous rock, it will be much more denser than igneous rock, because metamorphic rock it undergoes higher pressure and higher temperature. So that's where the rocks are much more denser. So gravimetric survey will give you some idea whether it is high density or low density rocks. Okay, it will show. Is there an example? Okay, so for example, just imagine this curve is an output from the gravimetric survey. So this line, the line that shows lower value, will give you low density material. Lines that show higher value will give you okay, for this case, this is per depth. Okay. It's just that basically the lines and the plots, if it shows a higher value, for example, this y-axis is your gravity value, okay, the density value. So if the plot is showing a high density value, it is showing the denser rock. If it's showing a low density value, it will give you a low density rock, which are the sedimentary rocks. So for your information, our petroleum system, the rocks in petroleum system are sedimentary rocks, so it shows a lower density, and the higher density rock are the igneous rock and metamorphic rock. And then between shale and also sandstone, shale is made up of clay, which are made up of mud, compared to sandstone, which are made up of sand. So as you know, sand is much more denser compared to clay or mud. So if it becomes a rock, sandstone will show a higher density value compared to shale. Okay. So again, gravimetric and magnetic can only give you the type of rock. Right. So seismic method. Seismic method is a method which generate a seismic wave. Okay, we will look into seismic wave propagating inside the subsurface. So these are the mechanism: refraction, reflection, and this is a method of interpreting a type of wave. I'm not sure if you go through the materials, there we have two types of wave. Okay, we have body wave and also surface wave. Surface wave means that wave that propagates only on top of the at a shallow layer, at a shallow depth. But body wave is wave that is able to travel inside the rocks. Okay, so body wave is able to travel inside the rocks, and body wave can we have two types. One is a P wave, primary wave, and the second type of wave is shear wave or S wave. So shear wave or S wave, they can only travel inside solid material, which are the rocks and minerals. But for P wave, primary wave, it can travel into both solid and also fluid. So P wave is the crucial one that is able to generate a complete seismic section. And that's why the geophysicists, they can interpret whether there's hydrocarbon or not because of the capability of the P wave, the primary wave. Okay, so the concept of refraction. Refraction, when you have a source, so seismic method can only be initiated when you have a source. Source is like an explosion to generate the seismic wave. So it could be on land, it could be offshore in the ocean. So in the ocean, we use the ships. There is ships to generate the sound. Ships to generate the sound, and the sound will travel into the rocks. And then on land, if this is on land, we usually put an explosion, something like a heating mechanism, hitting hard on the ground, and they will generate the waves on land. So for US usually they have their field on shore, on land. Like Malaysia, most of our field are at offshore, so our operation is much on at the ocean area. Okay, so the key important thing is that we want to know the travel time and the velocity of the seismic wave when it travels. So first, the original data of the seismic is based on time. This is actually the original one, have time. So when they go through processing, that's where they convert time into depth. Okay, so sound, as you know, if you learn the concept of sound, the crucial thing is the time taken for sound to travel back. That's how we know how deep the distance that the sound have traveled. And then we will convert it through mathematical interpretation to get the depth. Okay, so reflecting through rock layers. Okay, so this is how seismic section look like. The blue and red lines and some empty lines there because of the resonance or the acoustic waves. So this is the role of the geologists, again, geoscientists or geophysicists. They need to interpret these signals into layers. Okay, so for those in petroleum engineering, they just want to know where is the reservoir rock, and they will drill. For the geology background, they need to interpret this into the cross section. And then we have the electrical and mechanical part. Their concern is just on top of the at the platform area. How do they operate the facilities and everything? That involves all engineering background. For civil, usually it's on the offshore structure, offshore platform. You want to create a stable platform with balanced buoy and all those things. So we need also civil there. So all engineering could contribute into the oil and gas industry. Okay, so this is actually just a method of analysis. As I mentioned to you, we have surface wave and we have body wave. What I showed to you before is body wave, which are P wave and S wave. Surface wave, they are Rayleigh surface wave. We also have Love surface wave. Okay, so what it does is that it just have this it gives you some reading on just on top of the like planar view at a shallow depth, just planar. So it will give you some idea too on the image of the field. Okay, so this method is able to combine this wave surface with the body wave, with the S wave, and will come out with a better interpretation. Okay, resonance. Resonance will show you an interpretation again to give you a better interpretation of what does it look like at the subsurface. So they are able to make it into different color based on the resonance of the sound, and they will convert it into rock layers. How does it look like at the end of the day? And here it shows wells, meaning that the wells, this will be the reservoir rock. They have 3 wells there. There is a reason why they drill this well, especially this second well, which is quite near with this first well. Sometimes it's due to how complex the rocks there. So for this case, as you can see, there's a pink colored at the second well, because the second well just drill up to a certain depth, and the first well drills up to a deeper depth. So there must be a reason to that. So seismic could tell you why, the reason why. Meaning that, as you can see, between these 2 locations, there are different color regions between these 2. So maybe it will cause, it is the seal. So this will be a separate unit of hydrocarbon. The first hydrocarbon unit will be much at a shallower depth. That's why they require a second well. And the first well is exploring at a deeper layer, which to look into covering this, the one that have been interpreted at a particular depth. Okay. Okay, so this is onshore borehole, drilling through the land, on land, and then so you could have your receiver inside the borehole. So the practice for oil and gas offshore is we have the receiver lie on top of the at the surface of the ocean. Later I will show you one video of exploration in the ocean. So if this is on land, we could have the receiver on top of the ground. We place the receiver on top of it, or we could also have a receiver inside. So there are different ways of putting the receiver. Alright, 2D maps, 3D maps, 4D maps are generated through the seismic section. So now we could go up to the 4D mapping. So this is the process from seismic acquisition. Seismic acquisition is what you have seen before. The source of exploration, the receiver reading the seismic, processing and imaging is making it into a better resolution, and interpretation is usually making it into quantifying where, evaluating where is the petroleum system, which depth it is, how does your petroleum system look like, where's the source rock, where's the reservoir rock, seal rock. And reservoir characterization is the output showing the whole interpretation in a model, in a full 3D model. This is the reservoir characterization, and it will give you complete properties of the rocks. Okay, exploration well. Exploration well is the well that we just do it for try and error. So when someone interpret that, okay, I'm confident that at certain depth, at this particular depth, for example 2000 meter, I'm confident that there's oil in there. So that is where we deploy crew to drill for the exploration well. If there is hydrocarbon, we will continue to interpret, to create a appraisal well nearby and try to interpret the whole field. So what happened is that in reality, if you send your crew to that location and there is no hydrocarbon in there, you will be kicked out from the company. Okay, because the amount of cost required to send crew with the ships, with the paying the staff offshore, and then there's a lot of things to pay, and suddenly there's no oil there. So memang you will be kicked out from the company lah. So that is the reality. That's why even though the oil and gas they have quite a huge salary, there's a reason why their salary is huge, because of the risk, because of the profit that they could give to the company. Appraisal well is the well that we use to make, once we confirm that there's hydrocarbon, we want to interpret further how large is the hydrocarbon field, what type of fluid we have. We need to prepare facilities, especially for mechanical engineering. When you want to design your the facilities must be able to contain the type of fluid that you want to produce. So if you have a contaminated hydrocarbon, such as if you have content of sulfur or CO2, it is not a good thing if you have a poor material facilities, because it will cause corrosion at the material, which will affect the quality of hydrocarbon that will be produced outside the from the rocks. Okay, so that's why it's crucial lah to have good teamwork among all the crews, among all the different engineering background in the oil and gas industry. Okay, appraisal. Oh, that's all. Okay, is it ending? Okay, so that's all. I want to show to you a video. Okay guys, can you see the video?
Yes.
Okay.
Yes, we can.
Okay. So this is offshore exploration. So these are the receiver. Okay. We have a ship. Okay. So basically the video is showing how the operation of seismic survey for offshore. We have the hydrophone as the receiver, all the cylindrical tube that you see on top of the ocean, those are the receiver for ocean operation. So that's all from me. If you have any question, I can try to entertain.
No questions.
No question. Okay. So okay lah, I share the video here for those who cannot look at the video. So if there's no question, I think you need to log in for your attendance somewhere, Power Apps ke?
Madam,
Ah.
if the appraisal well does not work properly and it gives us false information, then what happens? I mean, like, is there any way of like helping?
Appraisal ke exploration?
Both.
You mean if there's a false interpretation ke?
Yes.
False interpretation. Okay. Okay. So first is that there must be when they go through all the interpretation, there must be a data and interpretation which will give you some because you still need to present to the board any decision before we explore or deploy a crew. You need to convince first the stakeholders and the board. Once they are confident with all the interpretation, they will call all the experts and look into all the interpretation. If it's convincing enough, then they will deploy the team lah. So if there's error lah, if technical errors which is not showing, okay, what happens is that maybe when they interpret at particular 2000 meter depth, they said they are confident there that there should be there, but looking into the data, at first it shows that there are presence, but when they go through, probably they are not. They do not found that hydrocarbon. They do not just like just shut off the operation immediately. What they did is that they will still go back to the interpretation part, try to look into what's wrong. That's where the quality assessment will be done to check back what goes wrong lah, which interpretation goes wrong. They will try to refine the interpretation and then they will try again. So to have a complete wrong misinterpretation during appraisal well is a bit uncommon, but for exploration well it's common to have try and error fields which does not have hydrocarbon. Tapi for appraisal well, because when they have success story from the exploration well, the appraisal well is just trying to interpret the field to get a better understanding. So if it fails at certain location, then they will just move to a different location nearby the exploration well. Sebab they have the success story already based on the exploration well. I hope I answer your question.
Okay, thanks, man.
Okay. Anything else? So good luck for your quiz lah. Next week, next Monday.
Do you have any questions?
What question covered?
Okay, I will explain after this, okay? Okay, thank you so much for Miss Nabila for 2-hour session with you. Okay.
Okay, thank you.
So, okay, can I have your 5 minutes? So I would like to ask, I would like to discuss with you on the quiz and also the problem that we're facing right now. Okay, since last week. Okay, I don't want to make next week class become like this. So I decided to divide your big groups. Is 300. Now we have 525 students here. So we are going to divide you into 3 groups. Okay. the class is still the same from 3 to 5 in Friday, but each of the group will be allocated only 40 minutes, okay, to ask a question, and then the lecturer will give you sort of a recap based on your previous open learning that you have that you go through, okay. So I think I hope that when I dividing your big class into several groups, it's okay with the BBB and also the Microsoft team. But I don't know, because when we are dealing with the BBB and also the Microsoft team is dealing with the server from UTP and also the vendor that being hired by UTP. So we don't know if the server is okay. So probably our class will be okay, because yesterday my class was very smooth, but I don't know what happened with this Friday. Maybe we have very high number of user this Friday, but it's okay. We try. Okay, for next week on Monday, okay, you are going to have a quiz, okay, starting from 8 a.m. until 10 p.m. Okay, I only need your 10 minutes time, okay, to answer the quiz. Okay, how many questions? Only 10 questions. What type of question? Is just MCQ. Okay, I repeat, how many questions? Only 10 questions, 10 minutes. Okay, but I open it from 8 a.m. to 8 p.m. because I totally understand that on Monday there's a lot of classes will be done. Okay, what chapter will we cover? Chapter topic number 1 and topic number 2. Dr. Said Mahmud and also Miss Nabila. Okay, so far any question for this thing?
No, sir. No, sir. No, sir.
Okay, I'm so sorry because we are facing the same problem again. I talked to the ITMS this morning. I'm afraid that the thing will happen again. Okay, but actually it's happening, but I cannot do anything. So we try to solve the problem next week. I hope that it can resolve the issue. Okay, so I think I will upload the video recording via ULearn. Okay, you can see your groups, okay, in the announcement, okay, at the ULearn. So any question before we end our class?
No, sir.
No, sir.
Okay, thank you so much.
Yeah.
Good luck next week.
No, sir. No, sir. Thank you, sir.
Thank you, sir.
sir.
Thank
Bye.
you, sir. Bye.
Bye.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Bye, sir.
Thank you. Thank you, sir.
Thank you, sir.